All right, first problem up. Given the sine of theta is 3/8, find the tangent of theta. And there goes that darn thing again. It's not a hard problem to do. You visualize a right triangle, you throw theta in the left-hand corner. You know the sine ratio is opposite over hypotenuse because you've written this down 1,000 times in your life. Unless you're one of the girls who's more interested in how long her nails are. The sine ratio is going to be 3 over hypotenuse of 8. And then you're going to do a little bit of Pythagorean theorem. You're going to go off the side and think about a squared plus b squared being c squared. So I have b, because my b's look like 6s. I don't know what the little egg is, but I know that a squared plus 3 squared is 8 squared. And I know that 8 squared is 64. And I know that 3 squared is 9. And I know that 64 minus 9 is a number, probably 55. So a squared is 55, so a is root 55, which does not simplify. Now, I did that because I want the tangent ratio. The tangent of this angle must be the side opposite over the side adjacent, and opposite is a 3, and adjacent is a root 55. And Mr. Milbrath has been telling you at least 4 times a day during the last 2 frickin' weeks that we're going to multiply the top and bottom by whatever that radical is, and I did not create that rule, so don't be mad at me. 3 root 55 over 55. Number 2, given sine of theta is root 5 over 6 and cosine of theta is something's wrong. One of them is supposed to be a negative. I changed that problem. Cosine is negative root 3 over 6. This problem is flawed too. Let's pause this real quick. That thing has 2 issues. Anyways, I had to fix the problem because the numbers weren't right and one of them was supposed to be negative. I changed this one to be root 33 over 6. The numbers didn't work when you did a squared plus b squared equals c squared. So it had to be thrown out. Anyways, first thing I actually can do here is I'm going to do all strippers take cash. I have here a negative cosine. Cosine is allowed to be negative here and here. Sine, cosecant positive, tangent, cotangent positive. So cosine is negative. And here I have a positive ratio. It's allowed here and here. This is where my angle lies. This is the triangle I draw. Now the sine ratio is opposite over hypotenuse. So opposite is a root 33 and the hypotenuse is 6. And the cosine ratio is adjacent over hypotenuse. So adjacent is a negative root 3. I did this to draw my triangle. And the tangent of this angle would be the opposite over adjacent. Again, you're thinking about all this SOHCAHTOA stuff. Opposite is a root 33. It's sitting over a negative root of 3. I can think about that as a negative radical containing 33 over 3 in it, which is a negative root of 11. Ta-da! There's another way of doing problems like this. If you can remember it, great. If you can't, you probably won't. I haven't talked about that with y'all because I didn't get as far as I wanted to. But tangent is defined to be sine over cosine. That is a trig identity. It's called a quotient identity. And if the sine is root 33 over 6, and the cosine is negative root 3 over 6, the 6's are in corresponding positions, and I get the same thing I had before. Negative root 33 over 3, which is negative root of 11. It's a shortcut to get through it. Angle theta, drawn in standard position, intersects a circle with radius 8 at the point root 39, negative 5. Find the secant of theta. You don't have to draw. In a perfect world, you would remember that the sine of theta is y over r. The cosine of theta is x over r. The tangent of theta is y over x. the cosecant, you can hear my phone, I'm getting torn up, is r over y. The secant of theta is r over x. And the cotangent of theta is x over y. So I want secant, which is r over x. 8x. 8 over root 39. Multiply by root 39 over root 39. And I get 8 root 39 sitting pretty over 39. In a perfect world, you would remember to do that. I'll be right back. I'm applying to something. All right, moving forward. Standing. This seems weird. Like, did something go wrong here? I guess so. I'm on number 4 now. Theta being drawn in standard position intersects the unit circle, which means I have a radius of 1 at negative 1/4 negative root 15 over 4. Remember, this is x, this is y. Evaluate the sine of alpha, and that is y over r. So it's going to be negative root 15 over 4 over a 1, which is just negative root 15 over 4. If you don't understand yet that something divided by 1 is itself, I really need you to pay attention to your children whenever you get older and have children. Like, you're gonna have to pay attention to them. The cosine of alpha is defined to be x over r, so just negative 1/4. And the one you're gonna have to work with, and I know it's the one that everybody's gonna be like, I don't want to do that, Milbrath. Tangent's y over x. So this one takes some work. Negative root 15 over 4, she's divided by a negative 1/4. Negative over negative is positive. 4's cancel. Root 15. It wasn't even that bad. It wasn't that bad. But anyways, so be it. Moving forward to number 5. Standing on a building 2,200 foot tall, you look down at a car. 2,200 foot tall. It's a tall building. It's like 40% of a mile. The angle of depression is 68 degrees, and that goes right there. The angle of depression is formed with the horizon. By a theorem called alternate interior angles, or it's a postulate, I can't remember what it's called, theorem or postulate, 68 degrees goes there. How far is the car from the building? Ta-da! What I have here is I have an angle, I have a side that is adjacent, and I have a side that is opposite. And I focus on the O and the A, I know that the tangent of 68 degrees must be 2,200 over x. And by God, I know how to multiply both sides by x. X tangents or cross multiplication, whatever you want to call it, they're the same thing, is 2,200. So x is 2,200 divided by the tangent of 68 degrees. So let's see what that is. 2,200 divided by the tangent of 68 shall be 888.86. Let's just take nearest foot, about 889. Convert negative 2.49 radians into degrees. Oh, the number of kids that will miss this thing is just going to be laughable. All I have to do is multiply the darn thing by 180 over pi. There is a formula for that. There is a formula for frickin' everything. But we won't bother to memorize them. What we got here? We got 180 over pi. There we go, negative 142.67 degrees. And I done forgot what it was, 142.67. And we're moving forward because I don't have all day. Consider a 6-bladed wind turbine with blade lengths of 75 feet. It's going to be kind of hard for me to draw here. Let's see, I need to space the blades out evenly. Start with 3. This is the pole, by the way. 4, 5, 6. If I take 360 and split it 6 ways, I get 60 degrees. All right. Find the length of the arc between each blade. Arc length is the radius times theta, but theta must be a radian. So I'm going to take my 60-degree angle and I'm going to multiply it by pi over 180. And I know that 60 and 180 become 3. 60 enters 180 3 times, pi over 3. The blades were 75 foot long, so 75 times pi over 3, which is literally 25 pi foot. That's the distance between these blades of traveling the path of a circle. Find the area between each blade. I have a formula for that. She is 1/2 r squared theta. So 1/2 of a radius of 75, that is squared, times theta, which is pi over 3. If you want, I don't know if I'm going to do this exact form or not. I haven't decided yet. But if I want exact form, I just push buttons without pressing the pi key. And use a 1 instead. I know that throws some kids off. 1875 over 2. Don't forget about pi, and that would be feet squared. If you see, if I decide that it's going to be a decimal, I mean, instead of a 1 there, you just put in a pi symbol. I really haven't decided yet. There you go. Or 2,945.2 square feet. It's whatever you want, really. I'll decide when to make the test out. Evaluate the cotangent of 5 pi. I know that 5 pi, that pi is worth 180 degrees, and this is going to be 900 total degrees, which I have no desire to graph. So I take away 360, and I take away 360, and I get 180 degrees. Weird, huh? Now, if you'll think about the unit circle here, this is a unit circle problem. Problem. I would be at 180 degrees at -1, 0. And if I'm thinking about the unit circle, the radius is 1. This is really what we do. And I know that the cotangent of an angle when using the unit circle is x over y. That's all she is, x over y, which is -1 over 0, which is undefined. Now, very few of you will actually watch this video, but cotangent is the reciprocal of tangent. This would be like doing 1 divided by the tangent of 900. Error, divide by 0, because it's undefined. Find 2 angles coterminal with 11. You could add 360 and maybe get 371. You could do it again if you wanted to. There's one. Be 731, or you could do 11 minus 360, which would be -349. You could take it away again, which would be -709. No, here's some more answers. Just find 2. I don't know if it'll be free response or probably multiple select. 10. Which angles are coterminal with 21 pi over 4 to select all? So let's take 21 pi over 4 and let's replace that pi symbol with what she's worth, and she's worth 180 degrees. And that'll give me 945 degrees. So this will be a little tricky for some of y'all, but if we take away 360, what are we going to have? 585. Now, something you might want to do is figure out what all of these are in degrees. This is 225 degrees. I don't know why I hesitated on that. I just did. So 29 times 45. 1,305. 855. Pi over 4 is worth 45 degrees, which is why I'm doing this. It's just easier for me to type. 1665. That one I know. That one's easy. That's negative 135. And that's going to be 315. So I don't see 585 yet. Maybe I take away another 360. And that's 135 degrees, which I also don't see. Sorry, I had a brain fart here. I'm a little confused as to what's going on here. Oh, it's right here. I told you I had a brain fart. There's one of them, 225. Don't see 585, 225. Let's take away another 360. and see if we get something. Negative 135. There's one. Now, I know that I'm not this one, but maybe I'm one of these two. So I started with 945. And if I add 360, I have 1,305. And if I add 360 again, I think I've got the other choice. 1665. There you go. There were three of them, four of them. Using reference angles and the 30, 60, 90 pattern, evaluate the cosecant of 11 pi over 3. So let's do that. Let's take our 11 pi over 3 and let's replace that pi with 180 degrees. This would be 1160s, or you can just push buttons in the calculator. It's 660 degrees. Take away 360. I'm going to graph a 300-degree angle. Which, by the way, I can also use the circle on this, and I'll show you what I mean by that. But a 300-degree angle is going to rotate here with 60 degrees left over. And I've shown you 30, 60, 90 patterns, whether or not you want to learn them or not. Here's one of them. Opposite of a 60-degree angle is a root 3. Direction makes it negative. Adjacent is a 1. Hypotenuse is 2. And cosecant is a hoe. She's hypotenuse over opposite. So negative root 3 over 2. Bam. Sorry, I did that wrong. She's a hoe. She's 2 over negative root 3, which is going to be negative 2 root 3 over 3 because we multiply top and bottom by root 3. You can use the unit circle. What you can do is you can think about the sine of 300, and you can look at a unit circle. I should still have that unit circle saved in my clipboard here, so I should be able to just paste it. And what I would see here at 300 degrees is I would see this y ratio of negative root 3 over 2. And if I flip it, I would have 2 over negative root 3, and I could then apply that beautiful magic to it. All right? These are also unit circle problems. Using reference angles in the 45, 45, 90 pattern, evaluate the cosine of 21 pi over 4. So again, it's 21 times 180 over 4. That's going to be 21 45s, which is getting on up there. What is that going to be? 820. I probably shouldn't do that in my head right now. 21 times 45. 945. And I don't want to draw that.
At this time, we pay sophomores that is not about to go to lunch.
225 degrees.
Last initials of A through K is you.
We'll rotate into quadrant 3 with a 45-degree reference angle. I imagine a triangle. I think about a pattern that I've been taught on 45, 45, 90s. It looks like that. 1, 1, root 2. Down 1, 1, 2, also back 1. I want the cosine ratio, so adjacent over hypotenuse. The cosine of 21 pi over 4 must be negative 1 over 2. Now, pay attention, that was 225 degrees. 225 degrees lies on the unit circle. So if I locate 225 degrees on the unit circle, if I shrink it up so you can see it, I'm going to be right here, and I was finding cosine, which is the x. I'm an idiot. I'm glad I checked it, though, because I missed it, didn't I? I'm really glad I did that, because the pattern is not 1, 1, 2, it's 1, 1, root 2. Did I write that and forget to put the radical? I should be getting negative root 2 over 2. Yeah, I didn't put the radical here. See, the unit circle saves the day, which I clean up by multiplying by root 2 over root 2, and I get negative root 2 over 2, which lined up with the unit circle idea. It's almost lunchtime. Do I work through lunch, or do I go hang out with people? Using reference angles in the 30, 60, 90 pattern, evaluate the sine of negative 120 degrees. That is going to rotate 90 and 30 more, leaving a 60-degree reference angle, which I've talked about in the previous slide. It's going to be a root 3 opposite, a negative 1 adjacent, and a 2 is a hypotenuse. And I want the sine ratio, and I know that sine is opposite over hypotenuse. So opposite is a root 3, and it's negative, and the hypotenuse is 2. By the way, if I take my negative 120 and I add 360, I get 240 degrees. And by God, you know what I'm going to do? I'm going to paste the unit circle again. Some of you will get this, and some of you will appreciate this. Some of you care less what I'm teaching. I'm not sure how you breathe every day. 240 degrees is right here. And I see this ordered pair. And I know that sine is y, which is that negative root 3 over 2. Don't believe me? Look at your own unit circle. I see it right there. There's the y value. There's my answer. Perfect. All right, I'll do one more. Find the measure of angle A and B in the triangle below. Round the nearest tenth of a degree, blah, blah, blah. All you do is you think, here's A. This one will be adjacent. This one will be opposite. So I know that the tangent of angle A is going to be 2 over 18, which means that the measure of angle A is the arctangent of 2/18. And then I go to my TLE4 and I push some buttons. The arctangent of 2/18 is 6.34 degrees. And unless you're a complete Patrick, you do 180 minus 90 that's given, minus 6.34. Push the buttons if you need to. I think you get 83.66. That should probably be checked. I'm pretty tired. Plus, I kind of want to stop doing this right now. I'm okay with that answer. It's an easy problem, at least I think it is. But what I think is easy and what y'all think are easy are just two entirely different things. But there's the first part of this video. There'll be a second part, obvious, and probably a third. None of you will watch it because you don't care. You're ready to be out of school. I'll see you next year.